Hello everyone, it's IT Chill here. Today I would like to talk about modes of operation. In any computers regardless of scale, such as smartphone, laptop and desktop computer, they will have their own fixed amount of built-in cores. Each core has 2 threads respectively. There may be a technical explanation on what is threads in computers. However, in this video, you will need to understand the following. Assuming the laptop has 4 cores, there are 8 threads. The laptop that has 4 cores are capable of doing 8 tasks in the same time. You may or may not want to further study on what is threads. This is all you need to know in this video. Assuming we have message or file that is very big in size, such as 2 GB, block cipher algorithm such as AES or China's SM4 accepts only 128 bits as its block size. How do we actually perform encryption or decryption on file or message? The answer is to separate the message or ciphertext into different blocks and encrypt them accordingly. If we just do that, we will face lots of security issues and vulnerabilities. After the message was separated into different blocks, how do we encrypt and decrypt those different blocks of message in a secure manner? This is also called as modes of operation. There are 4 common modes of operation, which are ECB, Electronic Code Book, CBC, Cipher Block Chaining, CTR, Counter Mode, and GCM, Galois Counter Mode. For this demonstration, I will use China's SM4 block cipher algorithm. If I use AES, I have to talk or mention about one of its parameter IV. I am not an expert to talk about the public parameter IV, which was used in AES. What you are viewing now is a diagram made by me. EK refers to an encryption algorithm which uses a key to encrypt message. M refers to message. C refers to ciphertext. By viewing on the diagram, you should be able to figure out how does ECB encrypt and decrypt message. If you have multiple cores in any computers, you can do multi-threaded version of ECB to speed up the encryption or decryption. However, if you recall on the padding video I made, you will realize that ECB mode does not solve the issue of people knowing the same encrypted password was being sent to the website. If the message such as message 1 and 3 was the same, the encrypted result will be the same. Depending on the situation, this might or might not be a threat to security. In cryptography, what we want to make sure is no one can learn something from the ciphertext. By using ECB mode, we allow people to learn something from the ciphertext, even though this has fast performance, but its security characteristic is not acceptable in modern industry. The diagram may look a little confusing, but this is how CBC works. In ECB mode, if any of the message was repeated, we will face an unsolvable security threat. We first encrypt message 1. We perform XOR operation between ciphertext 1 and message 2. We then put the XOR result into the encryption algorithm. This will come out a different ciphertext. This is slow because we have to wait for the encryption and decryption to finish. You cannot do multi-threaded version of CBC as it takes longer time to encrypt and decrypt huge data. The CPU cores cannot be occupied with encryption and decryption of data all the time, as they have other tasks to perform. Performance is also a problem here, but there is also a security vulnerability. If someone malicious stops and changes ciphertext 1 before reaching ciphertext 2, we will lose 2 blocks of message and ciphertext. If something happens to either ciphertext 1 or 2, the next encryption or decryption will not be properly performed. This is better than ECB, but it is not good enough. ECB and CBC has their own pros and cons. Would not it be nice if we have the speed and good security characteristic? The diagram looks a little confusing, but this is how CTR works. In normal CTR mode diagram, the nonce was labeled as +1 or +2. From my personal experience, we get the next nonce by hashing previous nonce. I think this is better than adding a number such as 1 to a nonce. The other possible approach is to just use random generation to generate nonce. This is a recommended approach because we use encrypted nonce to perform XOR operation with the message to get a ciphertext. Because the nonce was never repeated, the result of produced ciphertext is random. This is the recommended approach for block cipher in modern industry. I have made a video on MSC. You need to understand that after using CTR mode, you need to use MSC along with the produced ciphertext. We do not want the ciphertext being altered without permission. CTR mode is one of the stream cipher. We can do multi-threaded version of CTR mode as it takes short amount of time to perform encryption and decryption of data. I can roughly understand how GCM works. If you think you want me to explain how GCM works, please make a comment. For people who is not interested in how GCM works, you can assume it as CTR mode. The catch is we compute MSC in a special way while we are doing encryption. Block cipher in symmetric encryption, security-rated developers usually have implemented modes of operation for us. However, this is not the case for PKCS, asymmetric encryption, and digital signature. Asymmetric encryption was usually used in encrypting symmetric encryption key instead of encrypting files or big size of data. Digital signature was usually used in signing a message instead of files or big size of data. If developers need to encrypt or sign big size of data, there is no such feature for them to use. Let us assume the PKCS uses 2048 or 0.25 KB bits as its key size. The file or data size is 2 GB. If we try to separate the message into blocks and encrypt them, we can't avoid will make mistakes, which in turn turns into serious security vulnerabilities. If we do separation of data by our own, or encryption towards blocks of data, the bigger the data size, the more errors we'll make as a developer. I hope these sentences are enough to let you understand the modes of operation problem in PKCS. That's all for today. Thank you very much.